guys, welcome back to my channel. Today I'll do a really short video on temperature and its effect on reactions. But starting with a homework from my last video, I'd given you a reaction and I had asked you what will happen and what will be the change in direction of equilibrium if I increase the volume. So let's first count the number of moles. We have 2 moles on the left side and 2 moles on the right side as well. Because the moles balance each other out, then the answer will be no change. There will be no effect on the equilibrium. Then the second question, I gave you another reaction and I asked you what will happen if I increase the temperature. Now this reaction was an endothermic reaction, which means that delta H was positive. So increasing the reaction will change the direction of equilibrium towards the endothermic side, and hence the forward reaction will dominate. So there's a shift to the right. The third question was a reaction and the effect on the direction, the change if I had added if I add an heterogeneous catalyst. So the answer is there is no change in the direction, because as we already mentioned, catalysts have no effect on the direction of equilibrium. They only tend to increase the rate of the forward and the backward reactions equally. Starting with today's lesson, temperature. So the effect it has on reactions is it is like a catalyst. It increases the rate of reactions, but not by reducing the activation energy or providing an alternate route. That is for a catalyst. The temperature, it increases the kinetic energy of the molecules involved, and because of this they have more energy and they move faster and they bump into each other. There are more collisions and the reaction is more likely to happen quicker. So if we compare two reactions, increasing the temperature will allow the reaction to proceed faster than the one where the temperature is lower. Okay, there are 2 graphs that you need to know how to draw, 3 actually, but starting with 2, one graph for exothermic reaction and one graph for endothermic reaction. Again, I'll remind you, exothermic is loss of heat energy, endothermic is gain in heat energy. So we have 2 graphs, energy, kilojoules over time. And for exothermic, the reactants start at a higher energy level than the products, because with the products you're losing energy, so they go from a higher to a lower level. Endothermic, you start at a lower level, the reactants, and then they move on to a higher level because the products gain energy. So therefore in exothermic you have delta H is equal to negative, and in endothermic delta H is positive because of the rise in the graph. Moving on to the third graph, I'll take an exothermic reaction for example. We're going to show activation energy, the energy that the molecules in a system need to overcome or reach in order for the reaction to take place, in order for the reaction to proceed. So this is how you draw the activation energy. This is how you show it in the graph. So now moving on to the Arrhenius equation. So you have K is equal to A e to the power of minus EA over RT. So K is the chemical rate of the reaction. AE or A is the Arrhenius constant, or also known as the frequency constant or even the pre-exponential factor. EA is the activation energy. R is the universal gas constant or law, and T is temperature in Kelvin. Now moving on to the homework. Today I'll only give you one question, and it is draw a graph for the following reaction. You have calcium carbonate breaking down to form calcium oxide and carbon dioxide. The change in enthalpy is 76 kilojoules. That is it. I'll see you in the next video. Bye.